Hello again, my name is Konrad Kokosa, I'm one of Dotnetos, and today I would like you to describe and continue describing you this pull request, which was a pull request created for a ClrMD library, which is also called Microsoft Diagnostic Runtime, which is all about reducing allocations with the help of span and stackalloc. And as recently I was describing this method, which is to convert a data from a given address represented by a span to an unsigned int, today I would like you to describe a little more complex method. This method, called asPointer, is to convert a data and bytes represented by this span to a machine-wide data value, because we need something like, and there is something like, data which is machine-wide, which also means it is a pointer-sized value. It depends on the bitness of the computer. Today we have computers which are 32 bits or 64 bits, and depending on that, and in other words, depending on the pointer size, this machine-wide pointer will be bigger or smaller. So we need this condition here to have handling of both cases, handling 64-bit machines and handling 32-bit machines or compilations of the application. So in this case we have this condition here, and depending on the size of the pointer we are converting the byte array, the stream of bytes, to an unsigned int or unsigned long, because it is 4 bytes or 8 bytes, so we need to convert it to one or another. But the general logic underneath is exactly the same as previously. We are using MemoryMarshal, getReference, and Unsafe as to cast the data under the given address to reinterpret it as a given value. What I would like to show you today is that this code, which in fact looks as a quite complex code, because we have here this condition, we have magic calls to MemoryMarshal, getReference, to the Unsafe as method, so it seems that this code is quite complex. But if we look at this method from the perspective what in fact has been generated for such a method, it will be quite interesting to see how optimal code we get. Here I'm using the SharpLab site to decompile this code to the intermediate language. As we see, I have this possibility, like there are also other tools like elspy, denspy, but here I'm using online service for that. So I have this method asPointer, which is doing exactly the same, and the resulting el code seems to be quite complex also. Like we have these calls, we are just asking for the size of the pointer, we are just using these methods getReference and Unsafe. So still it seems the code is complex, but it is not, because if we will look at the generated assembly code, this code by the JIT has been tremendously optimized. Like all those magical calls and even this condition has been reduced to only 2 assembly instructions. This is because simply it is known at the compile time, I mean by the JIT compile time, what is the size of the pointer. So this condition can be hard coded in the resulting assembly. And then assembly code. And then we have these 2 simple instructions. We are just dereferencing the pointer which is pointing by the span, and then reinterpreting the address from under this pointer as a value of a given type. So this code has been tremendously improved on the JIT level, although in the C# level it seems to be quite complex. And also, as recently one of the guys on the Twitter showed me, this method could be also significantly reduced on the level of C# with the help of the specific type which is representing a platform. So instead of the condition, we are just getting rid of this condition here and just reinterpreting the data represented by the span as this machine platform specific data type, and then simply casting it to unsigned long. But still, the generated code is really impressively improved. That's fine for me. Thank you.